Everyone, thanks for coming. I'm on a mobile location, so if I get a little crackly, Alexander will keep me in loop and make sure our connection's okay here. They were going to tell us about who Innovative Solutions is, and we're presenting our PulseLogic technology. I'm going to try here, see if, okay, there's our first slide change. Innovative Solutions, we've been around about 15 years. We specialize in kind of new technologies and a different way of looking at energy conservation. Operational efficiency has kind of been our specialty over the years, but we've been focusing more from a demand perspective on energy conservation and energy savings recently. Our approach is a little bit different with our clients. We do full analysis, data collection. We kind of look at what the opportunity is, and then we match different technologies to what would be the best approach to achieving the goals of the client, and using also their kind of their corporate mandates, payback and that sort of strategies. And then we handle full implementation as well. So we truly are an A to Z type organization for all things energy conservation, operational efficiency related. The PulseLogic system, it's been developed over the last few years, and we've been just bringing into the Canadian marketplace, as well as expanding here. I'm Canadian, the company's Canadian, but most of our work has been global over the years. So when I say bringing this into the Canadian market, it's more because we just haven't done a lot of business in Canada prior to this. But looking forward to spending more time at home, actually. The PulseLogic system, it complements most energy efficiency type protocols that are in place, and it enhances
Sorry to interrupt you, Roland.
By 10 to 15. Sorry?
Sorry to interrupt. You just seem to be cutting out a little bit just now.
A little crackly?
Yes, if you can just maybe adjust whatever your phone, perhaps. Yeah, sorry.
Is that any better?
Yes, that's great.
Okay. There we go. The PulseLogic system, it focuses on energy efficiency of older devices. It's retrofit, and I mean, the simplest way to describe it is when you see an RTU that's 95% or 90% efficient, they've already done everything they can because you purchased a new RTU. A lot of the rooftop units or older boiler systems, they've been in place sometimes 10, 15, and 20 years. If there isn't budget to replace them, we'd like to consider ourselves the next best solution. Effectively, what the PulseLogic unit does is it adds the same type of algorithms or a new set of brains to an older system, giving it the ability to be more efficient. The cost per unit, it's around $950 per unit plus installation. It usually takes less than an hour. Usually, if the technician's comfortable with doing them, you can usually do them about 20 to 30 minutes. In most environments in Canada, we're seeing a payback of approximately 2 years. Actually, southern United States is going to see a quicker payback because of the warmer climate. And we support the product right out of the Toronto office here, and we have inventory in place. So it's not something that needs to be ordered and you have to wait for. And again, as I'll get into this, it covers the air conditioning as well as the heating sides and RTU, smaller boilers and chillers as well. So the PulseLogic operation side of it, it's a PDA-sized device. It's quite small, and it uses the embodied algorithms that to oversimplify it, just makes the system run smarter. It looks at it and said instead of delivering most air conditioners when you turn the temperature over to a certain level, it kicks in, goes into high gear until it reaches that point and then turns off. What the system does is it kind of looks at delivering you what your requirement is in the most efficient manner possible, opposed to dropping it all and delivering it by using large amounts of electricity. The same thing with a furnace. It does that. It oscillates the burner in order to deliver the most efficient means of getting the heat to you. And so, as it says there, it's like the cooling and the heating system. It works on either side. We've taken the slice out of the compressor cycle. So we developed this with the compressor manufacturers. Most compressors run the most efficiently if they don't operate for more than 6 minutes at a time. And the refrigerant starts to heat up, and when the refrigerant heats up, it becomes, the atomization rate is less efficient, so then you have to run the air conditioner longer to achieve the same goal. That's one of the little things that we do on that. And then I mentioned also with the heating system, we're oscillating the burner a little bit more in order to optimize, the burner temperature. Because you can only make a heat exchanger so hot, and once the heat exchanger is at its peak temperature, it doesn't matter what you do to it, you're not going to make it any hotter. So take it to peak, pull off, and then continue on. It's the fan using circulation, a boiler system, or a heating system, just letting the fan blow a little bit more. The PulseLogic system, it's patented, as you all, CSA, CE listed. It is actually a 24-volt device, so it actually doesn't require any of those, but we've gone to the effort of putting that on it. It's manufactured in the USA under ISO 2001, 2008 now. The plant, I think, is currently upgrading that as well. And we have over 10,000 installations in the United States. This is kind of a little bit of a breakdown how it works. It'll function, we have a couple different units. It'll function anything from residential, so smaller 3-ton units, all the way up to about a 90-ton unit. On the chiller side, so you're looking at packaged air, split air conditioning, heat pumps. It's very successful with heat pumps, and chiller systems as well, and both on the heating and cooling side there. As you can see, we've seen heat pump savings as high as 26%. Packaged air and split air systems are anywhere from 14 to 27. The joke we usually have is the units that were bought under the premise of the lowest bidder usually perform the best. It's how efficient the unit is. Like a 10 SEER unit, it gets very, very close to the 20% savings rating. As you get to a 12 SEER or 14 SEER unit, the savings diminish a little bit because it's already acting in a way that it's more efficient. A 30-ton chiller unit, again, it varies, usually 20, we've seen as high as 30. Refrigeration units, cold storage, usually around 14. We have another module that we can use for refrigeration that we push a little higher as well. We've seen as high as 40% on walk-in freezers. Just the way we control the temperature within the unit. Gas-fired boilers are around 28%. Gas-fired packaged heating units usually around 22%. We do really well with natural gas. We have a bundling. We can bundle this with some of our other technologies to push it even higher. Gas-fired boilers with closed-loop systems. We've seen 9%. We've gotten as high as 14 in some situations with the bundling of technologies. And something we're starting to see with boiler systems and with hot water tanks is some of the new logic that's being built in is very similar to this, where it's saying, leave the elements burning or leave the elements on for 8 minutes and then turn them on, turn them off for 2 minutes. So we're seeing a lot more timed activity or turning units off peak time when they're not in use. And then the last one there is oil-fired burners. Older complexes with oil-fired, we're seeing a little bit better than natural gas with those.
We have a question from Paul Roland. Does it have an application to an absorption chiller? My apologies.
Absorption chillers are a little bit of a tricky one. The way the system works is it works on stored. It works on stored energy. So if it's a closed loop system, it works really, really well. If it has, so with some absorption chillers, we're able to do something with them. Some of them we aren't. You have to kind of look at the technology. And there's some different models that have been built over the last 30 years that we end up looking at. It's just a matter of understanding how the system works and coming back. So it's that. The ones we can't do anything with are the fresh water systems that are in Toronto, because we require that closed loop. So we're using the temperature that's coming in and the temperature going out and creating a calculation and optimizing that loop. Oh, does that help? No.
We're just waiting for the responses, I think.
Yeah, I'm just waiting. All right. Just waiting for all the types, so see if I was close on the mark there or not. I can come back to that.
Yes, I was just going to say
while typing, I'll watch for it here.
Yeah.
Again, because this is relatively new, we have maybe a few dozen installations here. We're running a scenario with the city of Oshawa right now. Last winter we ran that full study, and once everybody gets finished arguing about what algorithms we should apply to the normalization data, we'll have somewhere between a 6% and 30% savings that we were able to show on the RTUs that we tested with the city. Okay, so it's a closed system, a district heating system. Yeah, we could probably do something with that. Again, the age of the system comes into play. If it's more than 5 years old, then usually we can do a lot. Now, Jim's asking about roof furnaces for a typical factory. So if it's a roof furnace or air makeup system, now if it's a rooftop system, it works really, really well. If it's the kind in factories that hang from the ceiling, it depends on the BTUs, because then it'll work on it, but it's a payback scenario. You know, some of the clients that we run into have a very strict 1 or 2 year payback. On the smaller gas-fired units, the smaller the BTU, the smaller the harder is the payback at $950. So it will work, but whether it financially works for the client is the challenge.
And then we have also a question from David. Are these approved by OPA and gas companies?
I'm sorry?
Are they? Is PulseLogic approved by the Ontario Power Authority and gas companies?
We've had the OPA has paid on a couple installations. What we do is when we install these, we're usually bundling with a lot of the other technologies that we do, and we just run a custom program. So we meter the results, and the OPA has no trouble paying on the ones we meter the results.
Mm-hmm. And then
Enbridge is a little bit more work because their programs are a little bit more dialed in, but we've been working for them for about 6 months to try and see if we can get something into a program with Enbridge.
And then Jim is also asking, I'm assuming, if you can join them together.
What it is if you have if I understand the question correctly, if you have an RTU where you have the heating side and you have the cooling side, what we end up doing is we end up controlling. You need a separate unit for either one. But if you have a series of heaters, like hanging from the ceiling of a factory, you can control 3 of them together. You don't want to do too many more than 3 because it's kind of working and controlling on the air in that area. So that's where when you end up being in putting too many of them together, when you're banging them together, it's more of a test environment. Depending on the environment, you 20-foot ceiling, 30-foot ceiling, but it can be done. So, okay, so that's it. I'll carry on with examples we've had in the U.S. here. Our energy office, we were able to do a little bit around there, and our Amoresco was kind enough to supervise the project with us, so we were kind of brought in for it. We saw savings on the heat pumps from 12 to 60%, the air conditioning 11 to 12. These were relatively new units, so they weren't too bad. And the boiler system that they had, it was an older system, so we saw 20%. Okay, sorry, I was just reading the notes to see if anyone else had any other questions there. We had a school that we did in Philly. It was part of an overall project of relamping occupancy sensors, HVAC retrofit. And it was kind of a neat project because with the entire bundling effect, we were actually getting down to about 1.5 year payback on everything. But we monitored the project over 5 weeks in the summer. First week of school, that's the sub-metering and kind of get it going there. To really get some hard data on a true environment. So their utility savings at the school was around $29,000. Electrical savings on the HVAC retrofits was $5,400 in the first year. Normalized 14% reduction. And estimate annual, the lamping stuff was different. And then the gas savings on the phase 2 system was 7.9K, which is one of the models in our PulseLogic line. we have a large chain in the U.S. They were so pleased with the first round of reductions. They're installing about 500 units to the bottom. It's probably all installed by now, and they're doing both the heating and the cooling side. You can kind of see there on the cooling season, the heating season, what we're able to achieve from a savings perspective. I guess now we're into open questions. RTU is a rooftop unit. That's how one question comes through for that. So that's the standard tan box that we see on the rooftop of pretty much every building from an air conditioning or heating perspective.
Are there any other questions from participants? So there's a question from Ronnie. So our rooftop setup consists of large engineered air RTUs, engineered air MUA, and 3 smaller carrier units. They are run by a Honeywell BAS system. Does your product replace the BAS or work with it?
Depending on the BAS system that's running, and if they have a maintenance side to it or a monitoring component, the BAS runs independent of it because we're optimizing at the unit level, and they're just controlling the temperature of the unit. So whatever temperature is irrelevant to the unit. So it does complement any building automation system. Some of the larger systems, we have to take a look at them to see how the controls are working on them. Some control systems have a tendency to not like the fact that we're manipulating how the unit runs. Some of the newer technologies, like when you get into the high efficiency units, we'll get alarms going off. But most of those are pretty rare, and we've gone up to a 60-ton actual air conditioners, not chiller units. So there's a couple different approaches. It is still a bit of a looking at, but it does not replace the BAS in any way. It's an augmentation. Did I cover everything in that question? Just looking. I think so.
Yeah. And I believe there's a follow-up question also.
It doesn't really, you can't really replace it. We have another system. We have a mini building automation system that we can run in conjunction with these ones to create that. It's part of our energy monitoring solution, and we have a thermostat that's controllable, and we can link the two of them together. So we've been asked, it was a project for one client they were doing that had 600 locations. So they wanted to have a building automation system of sorts in each location, controllable centrally. So we ended up building it for them. So we do have one, but it will not replace it, building automation system, but we can augment tasks to work like a building automation system. But it's not something you would use in a 100,000 square foot or million square foot facility.
There was a question from David. How is this different from the PACE controller you were testing?
We actually brought on board the inventor of the PACE controller, which is a little older technology, and that gentleman helped us be able to build the ignorant patent that we have on our PulseLogic system. So it's, I guess, the easiest way to describe it, if you're familiar with PACE at all, it is PACE on steroids. And we have a residential model that's actually going to be coming out in the spring as well. So it's just about refining all of it. Our PulseLogic line consists of about 6 different products. And so all of them either put together or singularly. Depends on everyone's situation. We create the PulseLogic line is designed to try and find the right solution for everyone's building. And everyone's building always seems to be a little bit different. So over the years, we've just added more and more technology to the line to see how we can do the most amount of money for our clients.
That's wonderful. Is there any other questions from the participants? I just maybe wait for a few seconds. I don't think I see anything. But thank you, Roland. That was a great informative presentation. If anyone has questions, you can contact Roland by email at roland@isinc.ca. I will be sending a recorded version of this webinar to everyone. so it can be referenced later on. And if you have any questions, you can always email me or Roland. Thank you for everyone for attending. I see a few people trying to type something here, so maybe there's a few questions, or I'm not sure if they're saying goodbye or yes. Okay, so Arthur Smith, do you have a GTA installation that we can talk to or visit, Roland?
Actually, I was really excited when Chris asked us to come here because, like I said, we're moving the technology in here. And if we have any potential folks who would like to be one of those first GTA installations, I mean, I do have the one in Oshawa, and so I can, but it's on a heating, not on a cooling cycle, the one we did there. Again, I can probably have the energy guy out there. You could speak to that one because we are actually moving into heating season now, so that's probably more relevant. And but we're looking for installations here in the GTA area, so I'm willing to do them at no cost. So if there's any volunteers that want to experiment and see what we can offer, all you need to do is ask. And so it's again, whenever you have 10,000 installations south of the border, but we need some Canadian ones. So I believe we're ready to do some catching up on that.
Great, thank you. We also have another question. Can you give us a little more information about closed loop system?
The idea with a closed loop system is imagine it doesn't really matter whether you're talking about water or you're talking about air, but how we manage temperature with an airflow system or a water flow system is we're pushing heat or cooling into a space. That space is going to be, is going to take that air from that space. It's going to get circulated through a space, and it's going to be brought back to the device and then reheated. What we're applying is a mathematical algorithm saying, okay, if I'm pushing out this temperature and I'm bringing in another temperature, what can I do to manipulate the outgoing temperature so the return temperature plus the space temperature is adequate to achieve the temperature requirement of the building? And that's where it gets interesting. So even from airflow or water, it's all about the mathematics between outgoing temperature and incoming temperature, because if we can reduce, if the incoming temperature is a little bit higher, and we can reduce the amount of energy it takes to bring it from that point to the point that we believe we need to heat that space. So it's the optimization between those two temperature points that helps save the money, if that makes any sense. I'm sorry, it's one of those harder things to explain, but it's outflow and inflow and the factor between the two of them.
Well, thank you. That was a great description.